I like to find the distance between a point and a plane. But this is a two-part question because the point happens to be the point of intersection between the two given lines. And so first we'll go find the point of intersection between the two given lines, and then we'll find the distance between that point and the plane. The intersection of two lines would mean that both the x's are the same, the y's are the same, and the z's have to be the same. And so we'll take that into account when we set the x from one line equal to the x from the other line. And so if these two are going to intersect, it would say that 1 plus t is equal to 3 plus 7t. What that will do for us, 7s. What that will do for us is that will give us a relationship between s and t. I'll try to keep my s's looking like s's and my 5's looking like 5's and my 2's looking like 2's. So it tells us what t is in terms of s. It tells us that t is equal to 2 plus 7s. So 2 plus 7 and then s. Alright, great. Then the y's being equal, we can take that same relationship. These are the x's being equal. Now the y's being equal, 3 minus t being 1 minus 8s, then what we could do is take the value of t that we've just found and plug it in. Not the value of t, but the relationship. And so we say 3 minus t is 1 minus 8s. And we have that t is 2 plus 7s. So 3 minus 2 plus 7s is equal to 1 minus 8s. What does that mean about s? Well, this will give us exactly what s is if the x and y are to be the same. It says that 1 minus 7s is 1 minus 8. And so it tells us then, I guess, that s has to be 0 because the 1's cancel out. And how could 7 times a number be the same as 8 times a number? And so it tells us that s is 0. If s is 0, then t is 2. And now we know the s and t that make x and y the same. Well, if it's a point of intersection, the z's also need to be the same. So we'll do a double check on the z's. For the z's, we have that 4 plus 4s with s being 0 needs to be the same as 2 plus t with t being 2, and it is. Okay, good. So we can now backtrack and find that point. The easiest actually would just be to, this is a true statement, so put a check. And so easiest thing for us to do would be to just take s equals 0 and read the point from the line. That we get 314. If s is 0, then the point is 314. So we have the point of intersection 314, and we have the plane given by the equation 2x plus 2y minus z plus 2 equals to 0. So that's our plane. We have our point, we have our plane. Now we need to be able to find the distance between these two. And there's a formula that we use. We derived it in class. It is that you can plug the A, B, C, and D from the plane, and the x1, y1, z1 from the point, and plug them to this formula. You'll get the value of your distance d. Okay, so let's go ahead and do that. A, B, and C. What's A, B, and C? Well, A is the coefficient on x in the plane, so this guy is a 2. B is the coefficient on y in the plane. That's also a 2. C is the coefficient on z in the plane. That's a -1. In the plane, the constant is called d, and that's a 2. Okay, great. And so the x1, y1, and z1 in this formula are from the point, and so x1 is 3, and y1 is 1, and z1 is 4. Alright, great. Let's just go ahead and plug in. What do we get? 2 times 3 is 6. 2 times 1 is 2. -1 times 4 is a -4 plus the 2. Now, in the numerator, there are absolute value bars, so that distance is positive. And then we divide by the square root of a squared plus b squared plus c squared. So that's the square root of 4 plus 4 plus 1. Conveniently, a perfect square. Root 9, which is 3. So our denominator is the square root of 9, which is 3. And our numerator is 6, because these 2 2's cancel this 4. The answer to the question is 2. The distance between the point of intersection between of those two lines and the given plane is